Professor Roman Leshkov, you have received the prestigious IACS Award and given a wonderful plenary lecture. What is the take-home message of this talk?
Well, we're working in a very new, exciting area of catalysis. For a long time, people have been excited about the use of electrostatics and electric fields to control reactivity, mainly in the area of electrocatalysis or in enzymatic catalysis, but never in the area of thermochemical heterogeneous catalysis. And this is mainly because people have not been able to connect dispersed catalysts with wires so that you can measure what's going on with the potential. So the lecture was about our studies and our investigations of how we can use potential or electrochemistry to drive thermochemical reactions that are non-Faradaic in nature. So in the first half, I described these new methods that we developed to polarize dispersed catalysts in a wireless fashion, so you don't need to connect wires onto all the different particles on the catalyst. And the second half was an explanation of how we can now use electrostatics to promote reactivity, particularly in Bronsted acid catalysis. And I showed how with this very broad class of reactions, we can actually get tremendous accelerations of rates in the order of 100,000-fold faster rates than you would do without polarizing that interface. And in the end, the main take-home measure, the conclusion was that for many decades, we have used these physical handles to control reactivity in terms of temperature, pressure, concentration of reagents. And my main message was that now we should add a fourth dimension for us to study in this idea of electric fields or electrostatics, that we have to measure the potential of the surface to be able to control reactivity.
Is innovation still possible in catalysis? What are the main challenges and how the challenges can be addressed?
Yeah, well, there's a lot of things that we don't know about catalysis yet, so I feel there's many areas where we can continue to innovate in catalysis. I would say there's two big ones. Number one has to be on trying to leverage now the new infrastructure or perhaps the new methods that we have with data science. So the idea that we can collect now large amounts of data sets and perhaps use this machine learning or artificial intelligence algorithms to find connections between a multidimensional space of variables and highlight areas where we have not been able to look into. And of course, you know, as when we look at catalysis from the physics or the chemistry perspective, in the end, we are bound by what we know on those particular areas. But with these new algorithms that are just math-based and in a way very black box-based, so they might not be bound by our intuition of chemistry and physics, we might find relationships that are unknown to us. And I feel that for that to happen, the community has to come together to standardize the data sets that we publish. So we have to have very good experimental protocols. We need to have very rigorous testing across different laboratories and be able to have repositories of data so that now we can have high fidelity data to be able to find these new relationships. And I think in the area of catalysis, we already are seeing it in the biological systems. For example, using artificial intelligence to evolve enzymatic systems in a much more efficient ways than before. And I feel that in material science, we're starting to see now some of these methods being deployed to find combinations of materials that we didn't know could exist before or with performance that we couldn't have. And I feel now with catalysis, that would be the next step. How do we do that in that sense? But it all depends on quality of data. If we have the bad data, this will never happen. But if we come together as a community to do this rigorously, I think we'll be able to unlock things in a way that we have not seen in the past. I would say that is perhaps the biggest one, in my opinion, where we can do a big change. And a second one would be on working at the interface of different areas. Again, how do we connect perhaps areas of biology, of physics, of chemistry to find relationships that we have not seen before? And part of, for example, of the lecture that I gave in the past is how do we connect the area of or concepts of electrocatalysis in non-Faradaic thermocatalysis. And I think there's a lot of similarities, there's a lot of concepts that we can apply from one area to another. And now decreasing the barriers between all these different areas should be, again, another gateway to unlock things in catalysis.
To your eyes, why the International Congress of Catalysis is important?
I believe that conferences are very important to disseminate information. And I must say, the ICC, the one that has been organized here in France, has been spectacular. The organization has been amazing. The quality of the talks has been very high. And I feel that we need to continue promoting these types of events. So as a community, the main way in which we communicate with each other is through papers, through manuscripts. And that way you can share the experiments, you can share results, and you share the interpretation of those results. The challenge is that many times those results come in already very delayed. So by the time you read the paper, the discovery was perhaps performed, several months to years before. That's number one. And number two is that there's way too many journals, and it's very difficult to keep up with everything that is being published. But now when you have all of this information condensed in a single venue where everybody attends and everybody participates, and you have multiple sessions that now summarize and keep you up to speed on the work that has been published and even unpublished work, that is essential for the community to spark creativity, to make connections with people, find areas of common interest across different researchers, and perhaps establish new lines of work. So all of these things I feel happen in the conference, and we have to continue working. I know it's a lot of work and it's a tremendous amount of effort to organize these types of conferences the right way, but I feel that they are essential for the community to continue to move forward.
Thank you very much for this discussion and interview, and have a nice time again in this Congress.
Well, thank you very much for the invitation. It was a really nice time, and I really appreciate the time that you had for the interview. Thank you.